In this tutorial we will learn how to make a simple terrain shader like this one, and we will make the mesh of the terrain on Blender, and then we'll export the file to Godot to implement the shader. I have here a new Blender project. I'm using Blender 2.8 beta, but the same can be done in 2.79, and I don't expect things done in this tutorial to change for the release version of Blender 2.8. I have to clarify that I'm using the new left-click selection convention. You can configure your selection preferences in Edit, Preferences, and then you should go to Input and select width left or right as you prefer. I'm using left click selection. The first thing we want to do is to select everything with A and then X to delete all the objects, and we want to add a plane, and we change its dimensions in the view panel to around 20 by 20 units. We go to edit mode with tab. We can make a right click over the plane, select subdivide, and in this pop panel that appears in the bottom left part of the viewport, we can expand it and put 20 in the number of cuts. So now we have a plane with a finer grid, and now we can exit edit mode. And what we are going to do with this plane is to add a displace modifier, which we can find here. In direction we select Z, so the displace is only applied in the Z axis, and in the texture slot we press new, and we can leave the default name of texture. We will modify this texture in the texture tab. In type we select anything that produces a noisy texture like clouds or noise or Voronoi, or anything we consider to be useful for what we want to achieve for our terrain. In my case I will use clouds, and in noise basis I will select improve Berlin. As you can see, the effect is not as strong as one could expect. To improve that, the mesh can be scaled up in the Z-axis on the view panel. On scale, we can put a value of 3 to increase the effect. To make the terrain look better, in the right-click menu, we can select Shade Smooth. Now that the terrain mesh is ready, we can export it as an OBJ file. We go to File menu, Export, Wavefront OBJ. In the Export OBJ options, it is important to have Apply modifier selected, and I don't want to grade the material, so I will untick this, and then I save the file somewhere I can remember for later use. With the terrain done, we can open a new project in Godot. So we make new project. I will navigate to my tutorials folder, and I will call this project terrain tutorial. Create folder, create and edit. And now that I have my project, I need to copy my terrain file into my Godot project. So I will look for my file, which is in here. I will copy it and paste it. And now Godot has imported the model, so I can use inside my project. We make a new 3D scene, and we get a spatial node as the root node of our scene. We can call it main. We save the scene with Ctrl S and we can leave the name as main.tsdn. Now we can add our terrain, which can be found right here, and we add it to this scene just by dragging it and dropping it into our scene. And this has created automatically a mesh instant node inside our scene. If we have a look into our transform, we find that it has some translation, so we can correct that by setting these values to 0, 0, 0. We can add a material to our terrain. So we go to the material section here and select new shader material, and in shader, new shader, and this we can edit in this text editor. And the first thing we should specify is the type of shader we want with shader type, and in this case we select special, because we are working in a 3D environment. And the first thing I will do is to specify the fragment shader, and we do that by writing a fragment function. And inside this fragment function I will assign albedo color that we can say to be green. And this is the simplest shader we can have for our terrain, but we don't want that. We will be making variations in colors depending on the slope of the terrain, and for that I first declare two variables with uniform, and this should be a color, which is a vector 4, and the first is the grass color, and I will use the hint color, and the next one is dirt color, and I'm using uniform because in this way we can access this value from the editor or even code, like in GDScript code. And here I will change this grass color to be something green, and their color something brown. And then we need to implement the vertex shader, and we do that the same way we did the fragment shader, just by declaring the vertex function. We are going to pass some value from the vertex shader to the fragment shader, and for that we need a varying, which can be declared here as varying float flatness. This variable will measure how flat is the surface for that specific vertex in the terrain, and we can calculate that by making flatness equal to the dot product of our normal and our y vector. So now we have this flatness value, and we can use it here in the fragment shader. We use the value of flatness to assign the color. So we make if flatness is greater than some value, this will be the grass region. Otherwise, if flatness is greater than some other value, this will be a transition region between grass and dirt, and in the last case it will be only dirt. So in the grass region we can say albedo equal to grass color.rgb, and we should remove this. And in the dirt region we do the same, we assign the dirt color to the albedo. And lastly, for the transition we should mix both colors, and we should go from dirt to grass, and to assign some amount here I will leave to 0.5 for the moment. And we have a problem. The problem is that we should only take the color part and ignore the alpha channel. So now that's fine, but we see that the terrain, almost all of it is just grass, so we have to change these values. So I will declare here a value 1, which I will take 0.9, and here this will be value 1, and then declare a second value, value 2, which is 0.8, and right here value 2. And I think this way is probably better. Yeah, and the right value for this interpolation amount is like that, flatness minus value 2 divided by the difference between these two values. In this way it has a soft transition between dirt color and grass color. We can add an extra feature to control the color of the grass, like a seasonal effect. For that I'm going to add a new uniform. Here I should put uniform float season, and I will use a range between 0 and 1. This season value will control the color of the grass. And first I need to declare the color for each season, so I have to do uniform vector4 grass, let's say winter color, and this will be color, and I can copy and paste this and just change this to be spring, summer, and autumn. So I will configure the colors for each season so it makes some sense. And now we just have to split the range of season that goes from 0 to 1 in 4 intervals, and we can include transitions between each interval. So transitions can have a length of 0.05 and the intervals a length of 0.2. I will start by considering the different values of season. So the first will be a transition, meaning if season is less than 0.05, then I have a autumn to winter transition. And the next case is if season is less than 0.05 plus 0.2, which makes 0.25, and this will be just winter. In the next case, season should be less than 0.25 plus 0.05, which is 0.3, and this is winter to spring transition. In the next case, season less than 0.5, and this is spring. The next case is season less than 0.55. In this case we have a spring to summer transition, and if season is less than 0.75, then this is just summer, and if season is less than 0.8, this should be summer to autumn transition, and the last case should be only autumn. Now in each one of these intervals we should modify the grass color. So now grass color shouldn't be uniform, so I will erase this part and now declare it here, and this is going to be vector 3 grass color, and of course well, that's fine, we can erase this. And of course now grass color is black, but we should assign the right grass color depending on the value of season. Now we have our grass color properly assigned depending on the value of season, and as we can see here we can modify this value and the grass color will change, like winter, spring, summer, autumn, but the value of season is not going to change very often in reality, and as we calculate the value of grass color in the fragment shader, it will do it every frame, which is not very efficient. So we can make this calculation outside the shader and then just pass the value of the grass color whenever the season value is changed, and we should do that from our node. So I will add a new script to the terrain node, and it should be GDScript. It inherits from mesh instance. It's fine to call it terrain.gd. I will create. I will just clean up all this code. The first thing I will be declaring is an export, which is a float in the range from 0 to 1, and this will be my season variable, and I will set it to 0. And I also need to export our colors, so it will be the same as in the shader, grass winter color, and I can copy this and just modify the season for each of the colors. This is spring, this is summer, and this is autumn. And as we can see here, we now have the season value, which goes from 0 to 1, and we can modify these colors to be the same as in our shader, or at least similar. And yeah, probably that's not the best combination of colors for the seasons, but I will just leave like that. What we want is to pass the value of the grass color each time season is modified. For that, I will declare the set and get functions for this variable with the setGet keyword, and this will be set season and get season. So for set season should be a function that has one argument, in this case is a float. So season is equal to value, and the getter is get season, and it's just return season. Now each time I use this set season, I have to notify my material that the green color has changed. But first I will calculate the green color just in the same way we did inside our shader. So all this code I will put inside my GDScript to get the value of the grass color. I have translated our shader code into GDScript code, and we have the exact same intervals than in the shader, and instead of using the mix function to interpolate between two colors, I use this linear interpolate. And finally, that we have our grass color, we need to pass this value to our shader. To do that, we get first our material with get surface material, and the surface is 0 because I have only one surface in my mesh, and I will use the function set shader parameter. Right now I don't have any grass color uniform in my shader, but I will declare it. So I will pass into my grass color variable the grass color, and I just need to modify my shader. Open the text editor, and here I don't need all this anymore, and I don't need any of this, and I just need another uniform vector 4 called grass color, and this is color. And of course, now that it is vector 4, I need to specify that I only want the RGB channels, and here dot RGB, and that's okay. So now I have the grass color controlled from my node, and I can change the value of the season, but nothing happens, and that's because I have to use this script as a tool script. And then if I go back here, I have to update this, and then I can change the color of the grass inside the shader with this slider. And this is the way to pass values from our node to our shader.